Okay, guys, so we are talking the remainder and factor theorems today. All right, so big concepts today, okay? And it has to do with stuff that you guys already know how to do, though, all right? So you're not really learning any new skills today. You're just learning how to apply them, okay? So the first thing is this remainder theorem. So let me break this down for y'all. So first off, the remainder theorem is talking about what the remainder represents when you divide a polynomial, all right? And the remainder, when you divide a polynomial, will give you the constant f of a. Now you might be wondering, well, what does that mean? Okay, so let's do this. Let me have you guys look at this example and I'll show you. All right, so we are going to just do substitution, which you guys did on your quiz, and you guys, that was a solid question. Let me tell you guys, did awesome on that one. All right, so method one, what we're gonna do is we're gonna be given this function, f of x, and I want you to find f of -2 by just substituting, okay? And to make this a little more fun, I will race you. All right, I will race you. When you are done, unmute yourself and say done. And that will let me know if you beat me or not, okay? But no cheating. If you started already, you are disqualified, okay? All right, so substitution. On your marks, get set, go.
Mrs. Leong, we tied.
Did we tie? Oh, yeah. Good job. Michael, I feel like you are my competition here. Good job. Okay, I'm gonna let everybody else kind of catch up. And let me clean this up a little bit too. And it takes practice, of course. And I've had a lot of it. Man, I've been teaching since 2006. Yeah, it's been a while. Okay, so hopefully you guys are seeing that it all boils down to 8. And yes, Angie, go ahead. All right, so that means f of -2, when we subbed in -2, gives us 8. All right, so we know how to do that. We know how to substitute, simplify. You guys are great at that. But now let me show you a new method. All right, and this is using the remainder theorem. All right, and what we call this, you can highlight this because in the directions, it might say to use this. And I want to make sure you understand what it means when I say to use synthetic substitution. All right, so what we're going to do is we're going to divide using synthetic division, all right, with that -2. So just like before, right, we would take all the coefficients of 3, +2, -5, +1, and -2. Double check if there's any missing terms. I see the degree goes 4, 3, 2, 1, and no. All right, so I'm looking at the exponents when I'm doing that, right? Exponent of 4, exponent of 3, exponent of 2, exponent of 1, no exponent. Okay, I don't have any missing terms, so I can go ahead and use synthetic division here. So big L, and that -2, oops, goes on the outside. All right, so -2 on the outside. And then we're going to do our synthetic division. So drop down the 3, multiply the 3 times the -2, and put that underneath the 2, and add. You get -4. Multiply that with the -2, and we get +8, and add. Multiply with the -2, we get -6, and add. Multiply that with the -2, we get +10. And then our last number here, we get a remainder of, oh my goodness, look at that, guys. We got the exact same number as when we substituted. And the remainder theorem tells us that the remainder, this number, will always be equal to the same number when we substitute in to that function. All right, so pretty cool. That is what this remainder theorem says. The remainder is equal to f of a. All right, any questions on that? You can either unmute yourself or type it in the chat. Any questions?
Yeah. Does that mean the substitution is like the same thing as division?
It's not saying that substitution is the same thing as division necessarily. Like, I think maybe you're over generalizing it. That's a great question though. It's just saying that when you have a function and you substitute it, the answer you get will be exactly the same as the remainder when you do division. Like the remainder, that number will always be equal to the number when you actually substitute. Does that clarify, Mateo?
Yeah.
Yeah? Okay. So those numbers will be equal to. Yes, those of you asking to use the bathroom, go for it. Thank you. Thanks for asking. Do ask me first. Yeah, that way if I call on you, I know, or I won't call on you because I know you're using the facilities. All right, great question. Other questions? Again, either unmute yourself or type it in the chat. Yes, you can use the bathroom. Yes. Those weren't the questions I was expecting, but hey, that's okay. All right, let's practice this. So number 1, it says use synthetic substitution to find f of 3 for the function that they give you. This f of x is equal to, okay? All right, now it specifically says use synthetic substitution, guys. So we need to use the synthetic division. All right, so let's check. We have exponent of 3. Oh, we're missing an exponent here. So we need to have that missing term, x squared, right? So put 0, and then the exponents go 3, 2, 1, and none. Okay. So now put in those coefficients, 5, 0, 2, and -1. And the number outside is actually exactly that number 3. You don't have to change the sign. It's just the 3. Okay, drop it down, multiply, add, multiply, add, multiply, and add. All right. And that is our remainder. So what that means is f of 3 is equal to that number 140. And that's it. So let's try number 2. I'm gonna start calling on you. Get yourself ready. We have actually 2 questions here. Use synthetic substitution to find f of 4 and then f of -3. All right, we're gonna do both of them. So help me with this first one, f of 4. All right, And let me call on Rachel. All right, Rachel, start us off.
So are we doing just f of 4?
Yeah, let's have you just do f of 4.
So you put the 4 on the outside.
Good.
You would do 1, 2, 0, and then 5.
Good job, Rachel. Oh, I wasn't sure. I was like, oh no, are you going to remember? And you did. Great job with that 0. Okay, keep going.
So then you bring the first one down and then multiply it. So it would be 4.
Okay.
So, and then 4 plus 2 is 6.
Mm-hmm.
And then 4 times 6 is 24.
Great.
And then it would be 24 plus 5 would be 29.
Oh, careful. 24, you got to multiply it with the 4. So that is 96.
Okay, yeah. And then it would be 91.
Oh, close. 96 plus another 5.
Oh, plus maybe 101.
There you go. Yeah. So remember, always add when it comes to synthetic. I know that's a little confusing with long division. You have to subtract, but with synthetic, you. So yeah, great job, Rachel. So final answer then, f of 4 would be equal to what?
101.
Perfect. You got it. Nicely done. Great job. All right. Let's try another one. Let's go to Maddie. All right, Maddie, try it out. I'll set you up.
Sorry, I keep misclicking on my phone because I'm on my phone right now.
That's okay. All right, so let's
Okay.
f of -3.
So what do we do with the -3?
Yeah, what do you do with that -3?
You make it positive.
Oh no, you don't have to do
Right?
that. Mm-mm.
So you just put the -3 in the box then on the side?
Outside the box. Yeah, on the side. Yep.
Okay.
Keep
So
it
when it's a function, you keep it whatever it is.
Yeah, exactly.
Okay. And then it would be 1, 2, and 5.
Oh, careful.
1, 2, 0, 5.
Yeah, why do we have to put that 0 there, Maddie?
Because you need the x. I mean, there should be another x value.
Perfect. Yeah, you're missing that x term, so you got to put the 0 there. Good. Okay, take it from there, Maddie. What do I do?
Drag the 1 down.
Perfect.
So 1. And then -3 times 1 is -3.
Perfect.
And that is -1.
Great. Uh-huh.
And -3 times -1 is 3. So
Perfect.
0 and 3.
Mm-hmm.
So just 3.
Mm-hmm.
And then 3 times -3 is -9.
You got it.
So it'd be -4.
Beautiful. All right, so finally.
And that's the remainder. So
f of -3 is equal to?
-4.
Beautiful. Perfect job. Nice.
Thank you.
Done. Awesome. All right, guys, that is synthetic substitution. Way to go. All right. All right, so I think you guys got that first part of the lesson down, but let me double check any questions before we get to our second part. Okay, all right, so the next thing I want to talk about, guys, is what's called the factor theorem. All right, and it makes, I think, a lot of good sense. The factor theorem basically says that if x minus a is a factor, if the remainder is 0. Well, that makes sense, right? If something's a factor, like 2 is a factor of 8, because when you divide it, 8 divided by 2, you don't get any remainder, right? Remainder is 0. But 3 is not a factor of 8, because when you do 8 divided by 3, you get a remainder. So a factor means that there's a 0 remainder. And we know from our remainder theorem that f of a is equal to the remainder. So if f of a is equal to 0, well, that means the remainder is equal to 0, which is why it's a factor. All right, so hopefully that kind of clicks together. All right, so let me show you guys an example. It says, show that x plus 5 is a factor of this polynomial, and then find the remaining factors of the polynomial. All right, so by the factor theorem, the binomial x plus 5 is a factor if -5 is a 0 of the polynomial function. All right, and by that I mean you get a remainder of 0. So let's use synthetic division with -5 on the outside. So I'm going to drop the 1, multiply, add. All right, and then multiply again. I get positive 15, and I get 2 when I add. Multiply again, and I get a remainder of 0. All right, and that's what I'm hoping for, right? So since the remainder is 0, x plus 5 is a factor of the polynomial. Okay, so whenever the remainder is 0, that means that x plus 5 or whatever you use to divide is a factor. Now, look at the numbers to the left of the remainder. Okay, these numbers to the left can be used to find what's known as the depressed, all right, not like sad, but like depressed, like it's condensed, all right, depressed polynomial. And it is x squared minus 3x plus 2. All right, using those numbers, right? My original degree was 3. So the depressed polynomial is 1 degree less than that. So x squared minus 3x plus 2. And that we can actually factor. So let's factor that on the side here. X squared minus 3x plus 2. X times x will get me x squared. -2 and -1 will get me positive 2. And when we cross multiply and add, we get that -3x in the middle. All right, so that can be factored as x minus 2 times x minus 1. All right, so that means actually we have factored the entire polynomial. So the original polynomial can be factored as the original factor I used to divide, x plus 5, times these remaining factors, x minus 2 times x minus 1. All right, so hopefully that made sense. We first divided with the factor we knew. And then with the depressed polynomial, what was left over, we factored that to get the entire thing factored. All right, any questions? Let me take a pause. All right, well, if you guys can't think of any, hopefully that means it's making sense. If not, that's okay. I'm gonna do a few examples to show you guys, and hopefully it'll make more sense after these examples. Okay, so let me do the first one, and then I will also, maybe I'll do 2, and then I'll have you guys practice with 2 of them. All right, so let me do number 3. It says, given a polynomial and one of its factors, find the remaining factors of the polynomial. Okay, so we are given the x plus 3 is a factor. So let's use synthetic division to find, just to make sure it is. Okay, so we have -3 on the outside. Okay, and we have 1, -4, -11, and 30 on the inside. And by the way, this number on the outside is always what makes this equal to 0. Okay, in case you're wondering, wait, how did I get that -3? Set that equal to 0, and that's the number you put on the outside. Okay. All right, do synthetic, drop it down, multiply, add, multiply, add, multiply, and add. And you should get 0 as a remainder, guys. If you don't get a 0 there, that means something actually went wrong, because they tell us that this is a factor, which means the remainder has to be 0. If it's not, double check, something went wrong, okay? All right, so now this is my depressed polynomial, which I can factor. So this is x and x, -5 and -2. So this is going to be x minus 5 times x minus 2. So putting that all together, that means the original can be written as the x plus 3 that I had to start with times the remaining factors, x minus 5 times x minus 2. And that is my final answer. Okay, any questions about that one? Okay, let me have you guys start. Well, actually, let me do one more and I'll have you guys start helping me. Okay, let me actually do number 5, since number 5 looks a little bit different. It has x to the 4th. Okay, but I'm going to do the exact same thing. I'm going to set up synthetic division. And I'm going to see my factor here of x minus 1, set it equal to 0, and I get x is equal to 1. All right, and we're going to put that on the outside of our synthetic division. And let me wait for my iPad to catch up. All right, now I'm going to put those numbers, coefficients in to my synthetic. I got 1, 1, -11, -9, and 18. Let's double check, make sure no missing terms. My exponent goes 4, 3, 2, 1, nothing. All right, so I'm not missing any terms. I don't need any zeros. All right, so let's now do synthetic. Drop the 1, multiply, add, multiply, add, multiply, add, multiply, and add. And phew, we have 0 as a remainder. That is great. That tells me I did it correctly. And now I have x to the 3rd, right? Because it's always 1 less than the original degree, plus 2x squared minus 9x minus 18. And that would be my depressed polynomial. Now we have 4 terms here, which means I need to factor this using grouping. All right, so let's factor this using grouping. And let's group the first 2 terms, pull out the x squared. Group the second 2 terms. I'm going to pull out the -9. And when I pull out the -9 from the -18, I actually do get +2. If you're not sure, you can always just redistribute and see if you get back to -9x minus 18. All right, we got twins. So we got x plus 2 times x squared minus 9. And that x squared minus 9, I can factor that more into x plus 3 times x minus 3. All right, so my final answer is I'm going to take my original one, x minus 1, and multiply that with the remaining factors. So this right here, guys, is our final answer. Okay, any questions there? All right. If not, let's try number 6, and then we'll see if we have time to go back for number 4. All right, so number 6, it says, use the graph to find all of the factors for each polynomial function. All right, so it gives it to us a little bit differently, but they give us this function right here. And they usually give us like a factor, right? And then from that factor, we were able to find out what number to put outside our synthetic. Now this time they give us a graph. And that's helpful because the graph tells us the zeros of the function. So we have a 0 here. It's where it hits the x-axis. We have a 0 here, and we have a 0 here. Now these two, I am not 100% sure I know what values those are, but I do know that this one is equal to +2. So that means, all right, x is equal to 2 is a 0 of the function. So x equals to 0, or sorry, x is equal to 2 is a 0 of the function, which means x minus 2 is a factor. All right, so we can use that and use our synthetic division. So I got 2 on the outside, I got 20, -47, 8, and 12. Let's double check. Exponents, I got 3, 2, 1, 0. All right, so I got no missing terms there. And we drop it down. Multiply, add, multiply, add, multiply, and add. And yes, we got 0 as our remainder. That is a factor. We are good. So let's factor this. 20x squared minus 7x minus 2. Oh, sorry, minus 6. And let's play around with this. We got -3 and +2 for the 6. Let me see. I think 5 and 4. Does that work? 20 minus, or sorry, 10 and 12. Not quite. Let's try 4 and 5. Does that work? -15 plus 8. Yep. All right. That one works. When you cross multiply and add, we get that -7. So you get 4x minus 3 times 5x plus 2. And we want to find all the factors is the question, all of the factors. So then we got our original x minus 2. And then we have our remaining ones from the depressed polynomial. All right, and that is our final answer. All right, guys, it is your turn to help me. Any questions before I start calling on people? Okay, then, here we go. Let's go to number 4, starting with Russell. All right, Russell, help me out. Number 4, what should I do first?
So the number on the outside would be 1.
Perfect, good. And then what numbers go on the inside?
They'd be 2, -1, -7, and 6.
Good. Do I need any zeros in that one?
No, we don't.
Good, nice. Okay, keep going, Russell.
So then you put the 2 down,
Mhm.
and then multiply the 1 by 2, and then put 2 under -1.
Perfect. Okay, keep going. Sorry, my iPad's trying to catch it.
Okay. Then we get 1,
Good,
and then multiply that by 1 and get 1.
good,
And then we get -6,
good.
and then 6 plus -6 is 0.
Perfect. And are we happy, Russell, to see that 0?
Yeah.
Yeah, why are we happy?
That means we did it right.
Yeah, and it means that x minus 1 is a factor. That's what it tells us. So yes, it means that we did it right. Good job, Russell. All right, let me jump to Michael Y. Can you take it from there?
Yes, so you have to write it out as 2x squared minus x minus 6. Then when you factor it out,
Plus X, but yes.
oh yeah, sorry. My bad.
No worries.
Yeah, and then you factor it out.
Good, okay. So what times what will get me the 2x square?
4 negative 3. Oh, that's just the 4 negative 3 is what factors to.
Oh, sorry. Or use whatever way you factor.
Oh, yeah, I used a different method. My
Yeah,
bad.
no worries. Go ahead and tell me, what does it come out to be?
4 x plus 4. Oh no, hold on. I did it wrong.
Oh, it's okay. Yeah, use whatever method. I know sometimes that's confusing.
Okay, so it should be I think 2x minus 3 and then x plus 2.
Great job. Way to bounce back. Nice. All right. So final answer, Michael?
2x minus 3, x plus 2, and then times x minus 1.
Perfect. You got it. Great job, guys. All right. That is it. Okay.